Continuing with what networking is and its protocols, block 2 on the unit list, we're about to tackle what an OSI model is. It is a theoretical model, though it can also be used to identify protocols and where to locate them, in which layer. We will see how protocols work and which issues they can fix. Besides, what OSI is, why we use it, and we will also walk through its 7 layers. Let's discuss something as easy as surfing the internet. It is effortless for us, the final users. The only thing we need to do is having a valid connection and searching for a website, for instance. In this case, we're going to search for a website called networkthinker.com. Here, as we type it and press enter on our keyboard, we expect to see some information. However, for this to happen, there are many protocols which are transparent to the final user, as, but necessary. Wireshark comprehends the way they work, at least most of them, and for the download to be carried out, many aspects need to be taken care of. For example, to whom do this data have to be sent? When we look up a website, such as the one we just saw, networkthinker.com, it is located in a server and we don't know its IP. Someone therefore needs to solve this. In this case, it'll be DNS. How often do we have to do this? How much data must be sent across? To whom shall I send them for them to be resent? To our gateway, for example, it needs to be searched for, found, and then to have an output. Besides, we need to know size and format, and there are other issues, such as whether we can send the data altogether, how to enter bits in the channel, if I have a message to be sent, could they receive it at the other end? I may be sending much, little, or nothing. Are the data I sent correct? And so on. As seen, many tasks the protocols need to carry out. In this chapter, we're going to break down the OSI model, so we have a better idea of which layer there are and how the protocols integrate in each layer. This is, which layer each protocol belongs to. Thus, when we walk about TCP, we will know where it is, same for UDP, or even knowing where something as simple as a PIN number is located, etc. With the purpose of having a better understanding of packet analysis, what Wireshark does, first, we need to understand the way those data are prepared to be transmitted. This cannot be done in any ways we want. Data need to be read in a very specific way, otherwise they couldn't be sent. OSI, Open System Interconnection, is a model which standardizes the functions of how data are transformed at different layers. But what is the purpose of this? Well, a developer, for example, can work in their own field, without having to rely on other areas of knowledge. Everybody is able to work in their areas of expertise and deliver the work to the next person in charge of a different area. This way, everyone is independent from one another, but also holding an interconnectivity. For example, a developer creates an application not caring about the means the data are transferred, and vice versa. A communications technician provides communication regardless of the data he's carrying. OSI model is a representation of how each layer provides services for the next one, and in particular, how these data are encapsulated as they get ready for transit. It means each layer is based on the lower one, does its job, and provides support for the upper layer. They are somehow independent, but not isolated. The two key concepts we need to keep in mind are independence and interoperability. The application layer. The user seldom interacts with application level. They usually do this via software, which in turn works at that level. It represents the user interface, delivering information and collecting commands which guide communications. This layer describes how application programs such as internet browsers, mail clients, remote terminals, P2P, etc. do their jobs. It is the only layer that doesn't provide service to any other, since it's the one on top. This is why data make for what we call the PDU, the data unit. Layer 6, Presentation. This layer is in charge of converting and ciphering the data into a format that the other end, either sender or receiver, may comprehend. But what use does it make to ensure that even though every terminal allows an internal representation of characters, sounds, and images, the data get across in a way that all of them can recognize? For example, JPG picture files shown on websites. This format makes sure that all browsers show pictures correctly, regardless of the operating system in use. It optionally takes care of compression and encryption as well. Some protocols related to this layer are JPG or QuickTime. In this layer, the data haven't been encapsulated yet, so the PDU, the data unit, are the very data themselves. The session layer establishes, manages, holds, and finalizes connections among users, processes, and applications. It is in charge of sustaining the link. An example of this kind of connection is the one between a database client and the server. The data are yet to be encapsulated in the next layer, so as before, the PDU are the data. The transport layer. Its basic task is to accept the data sent by the upper layers and divide them into small pieces when necessary to refer them to the next layer, the network layer. This means it is the one in charge of transporting the data from the source machine to its destination. Its function is to achieve a viable communication between final systems from one end to the other, ensuring that the data are conveyed in the same order and flawlessly, the former being key. Very common protocols of this kind are TCP and UDP. The data are divided into segments who are identified by a header with a port number. The network layer. Its duty is to make sure the data get from the source to the final destination, even if they are not physically connected. So, to connect networks. It also has to find the best route. This is allowing the data to navigate different interconnected networks, routing the packets from one end to the other. The information unit is therefore the packet. Some examples of network layers are IP, IPX, IGRP, ARP, or ICMP. Data link layer. Its job is to provide reliable communications between adjacent terminals. It transforms bolts into frames and frames into bolts. It takes care of physical redirection, network topology, network access, amplifying errors, etc. On this layer, the protocols carry out error control. One very recognizable layer 2 protocol that we all have at our homes is Ethernet. The data unit is the frames. At last we have layer 1. We decided to go from 7 to 1, which is the physical layer. It controls how the information is transferred to the physical media. It's in charge of media, connectors, electrical specifications and characteristics, bit duration, voltage levels, etc. The unit is the bit. To conclude, we're going to make a little review. We have seen how protocols solve many different and necessary questions. We explained what the OSI model is and its main functions, along with its 7 layers. On the next chapter, we're going through encapsulation yet to be seen. Thank you for your attention once again. Ciao!